Hello, everyone, and welcome to today's event. See what's new in Snorkel Flow 2024 R1 release highlights. I'm Matt Casey, Data Science Content Lead here at Snorkel AI, and I will facilitate today's event. Today's event will feature several demos that are pre-recorded. These were pre-recorded and pre-edited to make the most out of your time. And with that, it is my pleasure to introduce today's hosts, Daniel Xu and Vincent Chen. Daniel, can you join me on the stage?
Hey, Matt, super excited to be here. I am a product lead representing our enterprise functions here at Snorkel. Yeah, super excited.
All right. And Daniel, just tell the audience a little bit about yourself. What are you into? What are your hobbies?
Yeah, I mean, for fun, oh, wow, I have so many. I am a spear fisherman on the side, so I love to essentially free dive and try to go catch fish. I used to be a blackjack card counter a while ago, so had a lot of fun times in Vegas just beating up casinos. But done with that now, unfortunately.
Did you go to
Yeah.
MIT and I'm not aware of this?
I did not go to MIT. I went to Berkeley, but a lot of my friends did go to MIT and Harvard, and we followed in the footsteps of 21 at the time. So, yeah.
All right. And Vincent is our product director for AI and ML at Snorkel AI. Vincent, can you tell the audience a little bit about yourself?
Yeah, hey folks, very excited to be here. My name is Vincent. I actually joined Snorkel early on as a founding engineer after working on Snorkel, the open source project back when we were still a small project at the Stanford AI Lab. And over the last few years have been leading our AI and ML workflows within Snorkel Flow, our flagship product. So yeah, really excited to be here to share about our release.
All right. Sounds great. And with that, I will hand the show over to you. And here is our agenda.
Thank you, Matt. Well, welcome again, everyone. We're super excited to share with you all what's coming in our latest 2024 R1 release. A few pieces on the agenda today. I'll run through a high-level introduction for how we think about AI data development, how Snorkel fits in the picture, and really just in a narrative form, shape our perspective on where the AI field in general is today and how Snorkel fits into that workflow overall. I'll then jump into a few new feature deep dives with Daniel around some of the major feature launches that are coming with this R1 release. So without further ado, let's jump into the introduction. Wonderful. So in this next section, I'll really share our perspective on where we view the AI space today and where we view, frankly, enterprise value as sitting and living. And of course, how Snorkel Flow, we believe, plays a huge role in actually helping deliver that value and bridge that gap between prototype and production. So what we've seen over the last few months, and I'm sure folks in the audience have seen a version of this as well, is that the market has gone through quite the hype cycle. You know, there were periods when folks were saying, "Oh, AGI is going to take all our jobs," right? And AGI is going to obviate the need for any sort of customization or development of these models. And recently, we've really come around, or the market has come around to the idea that, hey, you do need some development. You do need a bit of customization to actually help hit certain production goals. Slightly, chatbots that lie sometimes are often not acceptable for enterprise settings. And so, again, the last few months have really helped drive this idea that generic models are not going to solve use cases out of the box. And our view, and it always has been our view, is that enterprise specialist models are really going to be what's critical to bridge the gap from prototype to production, right? There are several advantages when it comes to quality, latency, and cost that we view specialist models as being very important to delivering. And one way to think about this is this simple quad chart, right? In these enterprise settings, we're seeing that the higher the quality requirements, right, the more the need for high accuracy, the more the need to reduce hallucinations, the more the need for some sort of data development. Again, when you're in these enterprise settings, you often also see some amount of domain complexity, right? So more bespoke, custom use cases tend to require a bit more development. And so our point of view here at Snorkel is that, one, specialist models are going to be critical for the enterprise. And two, the way that you develop those models is going to rely on the data, right? Over the last few years, what we've seen as a trend in the market is that, you know, the models, our architectures, and the algorithms that are used to train them are actually largely standardizing in an interesting way. Sure, there are kind of advancements in terms of scale and number of parameters, but at the end of the day, the data is what is going to be critical for developing individual use cases and tasks. And how does that translate to enterprise teams? The highest leverage use of your team's times is going to be spent on the data, actually labeling, curating examples for evaluations, for training and fine-tuning and distillation. That's our point of view, and that's where we've seen a lot of leverage in real use cases today. And so what is the state of AI data development more broadly? If we agree that data is actually that key ingredient, there's actually a lot of pain in how folks are doing it today. You know, we've been out in the field, you know, working with customers, working with our academic partners. What we found time and time again is that this process of data development, actually getting from unstructured data to AI-ready data for the purpose of evaluation and fine-tuning, is actually quite painful, right? It's manual, painful, fragmented. It's really hard to find errors in your data, right? You might be prompting and leveraging an out-of-the-box LLM to start, but it's really hard to actually understand what to do next. Where do I focus to leverage my subject matter expert time best? You know, where do I actually label to actually build a fine-tuning training set that will be effective in production? Once I actually find those error modes, how do I actually crack them? What type of supervision do I provide, whether it be additional prompts, maybe some context from a RAG system, maybe some additional supervision or labeled data? Actually correcting those error modes, again, is quite painful, manual. We're seeing a lot of folks use, you know, Excel or you know, just raw notebooks strewn about, and that process today is quite ad hoc. The actual curation then of data that is going to move the needle in terms of fine-tuning and quality is actually quite hard to develop as well. And lastly, you know, we're still seeing silos in organizations where subject matter experts are sitting on completely opposite sides of the room to data scientists, when our view is these are actually the folks with the domain expertise and knowledge about how to define what good looks like, define the spec, you know, for how AI looks in production. And so our view here at Snorkel is, you know, all of this should come together in a unified platform and workflow. And so that's where Snorkel Flow comes in, right? That's where our flagship product, the Programmatic AI data development platform, comes in to really help with this challenge of data development more broadly. You know, from left to right, you know, our view is that, hey, teams should be starting with foundation models and data sources. You know, the platform itself is actually very flexible and agnostic to different forms of data and FM integrations. And after that, you know, you drive this process of what we call data-centric iteration, which is really, when you simplify it, two steps, right? The first is, how do I discover errors? How do I find where I should focus? What are the data slices where my model is making mistakes in an unacceptable way that I need to address? And again, this is a step that you can imagine is co-piloted by not just data scientists, but by subject matter experts who have the spec and understanding of what good looks like in their head. After you identify those errors, you have the ability to correct them with multiple forms of supervision. And the key idea here is that you're not doing this manually, but you're doing this with programmatic inputs, right? Labeling functions, slicing functions, filtering functions, different types of operators that will actually help programmatically provide software artifacts to correct and label and curate more data in a way that can be actually version control audited and collaborated on. So it's easy to adapt moving forward. Going through this loop, once you're done with that iteration process, the output of this system, of course, is either a specialist model, whether it be a fine-tuned LLM or some distilled ML model that's a little bit more focused in the task that it's trying to solve, or, you know, our customers and users have the option to export training data directly to plug into any sort of model training system that they're building in-house. And the key theme through all of this workflow is that data development should be seen as a form of software development. You know, all the advantages that you get with software, scale, you know, the ability to encode expertise in a version-controlled format, the ability to collaborate and adapt that software artifact over time, all of that is encapsulated into the way we've designed and architected our workflow. So as you hear about the features that we'll talk about in the rest of this session, you know, we'll come back to this general idea that, hey, a lot of what we're investing towards, a lot of the North Star that we're driving towards, a lot with your partnership, our very valuable customers on the call here. All of this is in service of making AI development look a lot more like software development, something that's, again, way more scalable, adaptable, and auditable, for these enterprise use cases and settings. So with that, let's jump into some of the release themes for the R1 release that we have recently shipped. So we have 4 major feature launches in this release, in addition to some continuous improvements that we've prioritized, all based on conversations with you all, to make sure that we're continuously improving the product for your enterprise use cases. So we'll talk through 4 primary themes here, all building up to the idea that we want to make it really, really easy for enterprises to develop data for their highest production workloads. The first theme here is going to be all about role-based access control. We're going to be talking about how we're making continued steps to empowering enterprises to make sure they have the controls they need to govern data within Snorkel Flow. Second, we're going to talk through some new LLM integrations that make it possible for enterprises to access the latest and greatest models like Llama 3 and Google Gemini in an enterprise-ready and secure way. 3, we're going to talk through some new and exciting foundation model-powered document intelligence workflow. So how do we actually drive, workflows from prompting all the way to fine-tuning over data sets that might contain PDFs, specific text documents, and we'll see a bit of a case study there from one of our solutions engineers. And finally, we're going to talk about new capabilities around image classification, which are quite exciting to really push the envelope in terms of the types of multimodal use cases that you all can tackle within Snorkel Flow. So with that, I will hand it over to Daniel, our enterprise PM lead, who will talk a bit about role-based access control.
Thanks so much, Vincent. I'm really excited. Hey, everyone. Once again, my name is Daniel. Today, I'm going to be talking about some of the new controls Snorkel will be launching for enterprise admins this year, specifically data upload access controls. This is going to be a recurring theme for the rest of the year. So we're going to be shipping a lot of data ingress, egress, and control features for your data governance and isolation needs. So make sure to stay tuned for upcoming webinars as well. They're going to be really, really exciting. At a high level, the enterprise IT admin cares about who has access to what features, data, and products. Why? The key problem Snorkel is trying to address in Q1 is specifically data ingress, or how data is brought into the Snorkel platform. For instance, IT may want to limit access to approved data connectors. All others should be turned off. And many customers have strict data security controls that prohibit file upload from the user's local desktop, right? Pretty standard stuff. As a result, using our new data upload access control features within admin settings, admins can now disable connectors for the new data set experience across the instance. Admins can also apply access control rules that gate access at a role or workspace level. For a deeper dive on how actually to set up these features as an admin, let's take a look at our pre-recorded demo with Matt Casey. I'm going to show you just how this works in real time. So the most basic case is a lot of our large enterprises are potentially uncomfortable with users uploading files from their local computer. As an enterprise admin, what I'm going to do is I'm going to essentially turn off the ability to do this local file upload. So in this case, I'm going to disable access to this connector. Once I disable it, if I go into this page here and I hit upload new dataset, I can see that local file upload as a data source is no longer selected. So I can click any of the other ones, but I can't click local file upload. And then when I turn this back on, and I go here, I hit upload new dataset, it's back on.
I understand there's more complexity to this. Can we move on to the more complex use cases here?
One of the other use cases that I mentioned is the concept of being able to set role and workspace level overrides. So a great example here is, say, for SQL database, what I want to do is I want to say admins and above have access to SQL database, but say nobody else does, right? So in this case, what I'll say is admins have access to this across all workspaces. So in this case, only admins have access to SQL database because I've explicitly indicated that they have access to this dataset upload method. So when I go to here, where I am an admin within Workspace 2, I can still see that, hey, I have access to this connector, right? So I can still essentially make use of this. But in this other workspace, where I am essentially a annotator, developer, or reviewer, if I try to then upload a data set, SQL database is turned off.
So these controls can get a little bit more granular, right?
Yes, that's absolutely the case. So I'm going to show you an example for Databricks SQL, where in this case, what I'm going to say is for admins, they have the ability to not only access Databricks SQL, they have the ability to create and update existing configs. Whereas for all other roles, they only have the ability to view existing configs and use them, but they can't actually edit them. So let's go in. So what I'll say is, hey, for admins, I will allow them to create, delete, read, and update existing configs. So I will do this for workspace 2. Then I'll add a new rule for Databricks SQL. I'll only allow this to be read and use existing. And I'll say, hey, for, say, developers within workspace 1, they will only be able to read and use existing Databricks SQL. So if I go to upload new dataset and I go into Databricks SQL, what I can see is, hey, this config already exists. So when I want to essentially edit it, I can. So I'm currently in workspace 2. I'm an admin, so I have the ability to create, read, update, delete as an admin within workspace 2, right? Notice that the access token, even though we already persist the configuration, is not visible to the user. So that's a security benefit. However, if I am in workspace 1 and I try to use Databricks SQL, you can see here that I can only actually use existing test config, but I can't add and I can't modify it. So in this case, it's only visible to me and I can use it, but I can't actually change it. Now, as an admin, I have much finer grained control over who has access to what configuration. Sometimes our enterprise IT admins want the ability to essentially define service account controls, or they want the ability to define shared configs that everyone should be able to have access to, but nobody should actually be able to modify, right? So think of this as like, hey, this specific workspace that belongs to this specific team, only the team admin has the ability to configure which data source or data lake they should be able to pull from, but nobody should be able to actually modify that underlying credential. So they can make use of that credential, but they can't see it, and they can't actually do anything with it besides just use it. They can't modify it. Awesome. So that's me in a nutshell. Passing it over to Vincent.
Awesome. Thank you, Daniel. Super excited about how these capabilities are going to up-level controls that enterprise have access to. And as Daniel mentioned, this is only scratching the surface. We'll have a lot more here, again, based on partnership with many of you on the call that we've built a roadmap around. So next, I'm going to talk a little bit about on the theme of enterprise readiness and making sure that a lot of our partners and customers actually have access to the latest and greatest LLMs in enterprise-ready settings. We're going to talk a bit about expanded LLM integrations, such that our customers can access the latest models like Llama 3 and Google Gemini. So a lot of our customers have told us that, hey, to avoid lock-in, and more broadly increase flexibility to test out different LLMs easily and securely within their enterprise environments, they needed a step change in terms of ease of use when it came to a lot of these LLM integrations. So we're very excited to announce that with this release, we've really increased the flexibility and usability of a lot of these integrations so that you can actually access some of these really exciting new models for like Llama 3 from Meta, Google Gemini, and use them directly in Snorkel Flow. So the goal here is to enable folks to integrate these custom LLMs via our SDK. It's a one-liner to now pull in and configure a lot of these external LLMs, whether they're hosted or on-prem in a local way, and use those to then create custom prompt templates and scale data labeling really quickly and easily to power a number of those data development features within our platform. So to make that a little bit more real, I'll actually toss it over to Huang, one of our research scientists, who'll show a little bit of a demo for how he used this capability to power some exciting new projects on the research side.
Hello everyone, I'm Huang, machine learning engineer at Snorkel AI. We are very excited about the new Google Gemini's model suite, and as soon as Gemini Pro was released, I really want to check it out. So today, I'm going to show you how machine learning teams using Snorkel Flow can access Gemini Pro directly within the platform to build specialized application. Snorkel Flow is a data development platform focusing on data operations, which including but not limited to labeling, filtering, or augmentations. Traditionally, for developing high-quality training data, you would start by manual labeling. Now, with the power of foundation models or large language models, you can start with the model prompting, see the error modes, and iterate on that output using different tools. So here is our prompt suite. As within the last release of Snorkel Flow, we have already expanded our library, large language model library, to include Prompt 2 and other models in the Vertex AI model garden. So you users can access a lot of models, which is available from the dropdown inside the interface, and apply your license key directly. Now, how about Gemini? First, huge kudos to the Google team for releasing Gemini as part of the Vertex AI model garden, which make it really easy to integrate. Behind the scenes, here's how we register. Simply running this code, which is registering Gemini Provision within Snorkel Flow. SF stands for Snorkel Flow. And after I run this and refresh the previous page. So now, let's wait for the refresh. Now, coming to the prompt page, now you already see Gemini Provision already appearing inside Snorkel Flow. It's that easy. So that fast, and then you can do few shot chain of thoughts. You can use Snorkel Flow for guided model analysis. So right here, I'm trying a new prompt, adding some more description to the labels, and kick off the job. So you can do a lot of prompting, few shot chain of thought, everything inside Snorkel Flow, and you can also utilize our proprietary error analysis tools to query your data, address incomplete or inaccurate issues, skill distribution, etc. So a lot you can do a lot of things in here, and you can see the percentage is really good. So yeah, and then you can use Gemini Pro as your base model to develop your specialized tasks in different scenarios. Again, huge kudos to Google team for making Gemini so easy to access from the Vertex AI model garden. And I'm really excited to start working with Gemini and look forward to sharing more insights later on. But yeah, that's all. Thank you.
Wonderful. So what you just heard from Huang is actually quite generalizable across a number of model integrations. It's just as simple as that, right? A one-liner to integrate with one of these latest and greatest LLMs. In this case, we showed some of the exciting new capabilities from Google, one of our cloud partners. And moving forward, all of our customers will be able to use those same integrations to power a number of their, data development workflows with the latest and greatest models here. So yeah, thank you so much to Huang. So charging ahead, that is actually a great segue into what I'll be sharing next about, which is our foundation model powered doc intelligence workflows. More broadly, these capabilities are going to really help us move from prototype to production around a number of use cases surrounding PDFs and text-based documents. And so the premise here is, in traditional document intelligence workloads, there's a set of tools out there today that allow you to chat with your PDF. There's a set of tools that allow you to, maybe fine-tune some of these models based on labeled data. One of the unique components of Snorkel is that we've actually launched a new workflow that allows you to go from prompting to fine-tuning all in a single application. So the goal here would be, you get started quickly by using prompting to label your data directly within the Snorkel Flow UI, and then you can actually see the errors of those prompts. You can actually see where the model's doing really well and what examples it actually generalizes right out of the box to. You'll also be able to see where that model falls short and where there are specific error modes that you need to correct in order to get to a high quality application. So in general, we're really excited about pulling in prompting to our PDF workflow specifically. And we're really excited to see how you all put it to use, because we have seen some really exciting evidence about how folks can now move from, again, these early prompting experimental workflows all the way to fine-tuning to make sure that we're shipping applications in the document intelligence regime with really, really high value and production accuracy. So I'll tee it up for Algis, one of our lead solutions engineers, in the next slide, who will share a bit about how these workflows and new capabilities can be used to solve some real-life document intelligence use cases from some of our customers and partners. So over to Algis.
Hey everybody, Algis Casnunis. I'm a senior machine learning solutions engineer at Snorkel. I'll be walking through just like kind of one iteration or one development loop in Snorkel, leveraging the new prompting workflow for PDFs.
Where do we start?
I'm going to show some work that we've done with a top 10 US bank where they wanted to build out a specialist model that was really well trained to extract out interest rate derivatives out of financial documents. So what I've loaded in Snorkel here are 10Ks, financial statements put out by various publicly traded corporations. And one of the holdings that they might have are interest rate derivatives. So what we want to do is teach a model to understand these very specific line items that sometimes occur in tables and sometimes occur kind of in the text of the 10K. So we want to kind of make sure that this model is extracting these entities from various portions of the document. A natural way to start is just asking a large language model to see what it understands and see how well it can identify interest rate derivatives. And I'm going to do that using the new prompting workflow in Snorkel Flow. And I'm going to go into our prompts tab where I'm able to connect to multiple large language models or foundation models. Today I've connected to GPT-4 as well as the layout LM model from Microsoft. Let me ask the ChatGPT-4 model to extract out interest rate swap notional amounts from my documents. I can preview this prompt in Snorkel on a small subset of data, and I can start to understand how well is this prompt performing at the specific task that I've instructed the large language model. What Snorkel tells me is that this particular prompt is able to respond at an accuracy or precision of 67%, and it's able to cover a fraction of 1% of my data. Snorkel allows me to take a look at when this prompt is performing or where this prompt is performing correctly or incorrectly. Let's take a look at an example where the prompt is performing correctly so I can sanity check the output of this prompt. So what we can see here is just sanity checking this prompt is actually identifying some positive mentions of an interest rate swap, right? We can see it says interest rate derivative, and the large language model correctly infers that this is a interest rate swap. I'm fairly satisfied with the performance of this prompt, and I can go and create this prompt. We also have this other labeling function that's actually pretty good. It's starting to identify concepts like liabilities and debts. So what we can do is ask Snorkel to programmatically label our data set, and we can train a model. This model is going to essentially form or work as a compass. It's going to point us in the direction where we have additional room for improvement. I've already trained a model here, and we could take a look at the performance of the model that's already trained. And what we can see is that Snorkel, by programmatically labeling our data set using the outputs of those two prompts, is able to train a model that's performing at 60 on an F1 score. However, this is nowhere close to being ready to push into production.
So can you show me how we would find a specific error mode and then go about correcting it?
Yeah, absolutely. So as I mentioned, I like to think about this model that's being trained kind of as the compass. And Snorkel opens up a lot of different error analysis tools that you can use to identify those error modes and also some strong recommendations of how to make those corrections. An interesting one to point out here is this concept of a clarity matrix. And the clarity matrix shows us where we have potential data errors as well as model errors. And really critically, where those data errors result in model errors. So Snorkel is basically telling us, hey, take a look at these couple error modes and provide me more information of how to interpret particular entities. So I can click into these and Snorkel auto filters my data to this error mode. And what I could see here is that Snorkel has not been able to identify, or the model trained in Snorkel has not been able to identify these four particular line items correctly as interest rate swaps. But for me as a human, it's really easy to realize that these are interest rate derivatives. It says interest rate derivatives, it says interest rate swaps, and it also says fix the variable, which I know applies specifically to these particular derivatives. So to resolve this error mode, what I want to do is fix this using a corrective programmatic labeling function. And what I could do is basically just tell Snorkel very directly, hey, when you see interest rate swap, interest rate derivative, or fix the variable, I'm just going to auto-populate this really quickly, you should identify this as an interest rate swap. And in the same way with as I wrote my prompt labeling functions, I could also look at the precision and coverage of these kind of corrective labeling functions as well, or pattern-based labeling functions. And what I see is that it's not perfect. It's about 87% precise, but it covers about 2.6% of my data. what I'm able to do then is take the relabeled data set and train a new model. Snorkel has more than doubled the size of our training set, as we can see up here. And we could go now train a second model in Snorkel. I can call this now like something like model 2, so that we're not waiting. I've already trained the second model for us on the updated data. And what we could see now is that Snorkel is able to kind of improve the performance for this specific task now to 82 or 83 on an F1 score. And what we would do next is basically rinse, lather, repeat. Well, we can take a look at the error modes that still exist, and we could go to refine them. And every single iteration in Snorkel, we're basically going to do that. We're going to provide kind of additional signal through a programmatic labeling function, relabel our data set, train a new model, and identify those errors.
So that's the loop, and you just continue the loop until you hit your target metric, and then you deploy it, right?
Yeah, absolutely. Typically, kind of at the last mile, you might want to kind of pull in maybe an SME to help you understand maybe like those more complex error modes. We might iterate a couple more times, resolve the remaining error modes. And then when we're happy with the performance of the model, we can either export the programmatically labeled data set, or we can export the model that was trained in Snorkel.
Wonderful. Shout out again to Algus for that particular demo. What gets me most excited about it is it's really bridging some of those gaps that I and other, data scientists and ML folks have seen around, hey, how do I actually get started with this lightweight prompting type interface, see how this off-the-shelf LLM is doing, and bridge that gap with corrective labeling functions, corrective sources of supervision, all the way into a fine-tuning workflow. So very excited to get this into all of your hands to help with your document processing and intelligence applications. Back to Daniel.
Yeah, thanks so much. For our final product launch today, we're going to be talking about how Snorkel now provides support for some computer vision tasks. Yeah, specifically, Snorkel now provides first-class support for programmatic image classification as a new data modality alongside of our text and PDF data types. We originally developed this image annotation capability in partnership with Wayfair for retail and product tagging use cases. If you'd like to learn more about that specific retail and computer vision engagement, where Snorkel helped Wayfair improve their labeling accuracy with an F1 macro score by over +30, and also enabled a +5% increase in add to cart rate, please reach out to a Snorkel account representative after this call. We'd be happy to set up a demo for you, and we'd also encourage you to watch our dedicated Wayfair webinar on YouTube. Without stealing too much of the demo's thunder, I'll quickly give a summary of platform capabilities. Snorkel enables data scientists to perform natural language semantic search and filtering over your product images, or perform image similarity search over your dataset. Finally, you can leverage the existing text-based labeling functions that you already know and love to incorporate additional relevant text metadata, like product captions, to enhance and improve the performance of your image annotation workflow. For a deeper dive on how to actually perform these image annotation workflows, let's hear more from Tom, who has set up a pre-recorded computer vision demo on the Wayfair retail use case.
I'm Tom. I'm a solutions engineer at Snorkel, so delivering different technical solutions to our client. So I'm going to show you a computer vision demo of our classification apps, where we're going to be programmatically labeling at scale and then training specialized models specifically for images for classification.
And we're looking at 3 different paths here, right? So we have programmatically labeling images in Snorkel Flow, training specialized models, and using analysis, right?
Exactly. And we're going to see that this is all going to be in the same application. There's going to be a flow to it. We're going to be doing that programmatic labeling. Then we're going to be training our models and then looking at analysis to see where are different errors coming from and how can we correct those. So just as a little background, we've done work with Wayfair. This is going to be a proxy application representing that work that we did do with Wayfair. So just to start off, we're going to be looking at area rugs. If I click into an image here, you can see the different types of labels we can have associated with it. This is going to be a multi-label application, which means we could have multiple labels for each image. You could see some of the examples here. We have quite a few, but you'll see that P is here representing present for the label, A is here representing absence, and this question mark represents that it's not currently labeled, but we will be labeling it programmatically in the platform.
And also, if we had a subject matter expert in here, they could individually label these. Is that correct?
Correct. So you could go through, look at each image, and label it one by one. We always do start with a small portion of ground truth data, and then the rest we're going to label programmatically at scale. And this is something that's scalable for Wayfair specifically. They were looking at a ton of different tags looking at hundreds of thousands of images. We were able to work with them very quickly to build up a training set and give them specialized models they needed in a matter of weeks as opposed to months or even longer.
Sorry to run you off track, but let's continue.
The first one I want to show is an image-to-image labeling function. So I'm going to look at this particular image. We can see it's a circular shape. So I want to find other similar images that represent this shape, and we're going to use the label rounds. So if I quickly preview this image labeling function, I can see which images are most similar and then least similar as well, represented in an embedding space. So if I toggle this, we'll first start with most similar. I could see which images are encapsulated in this particular batch, and they'll appear down below. And we can see that most of these do fits that round shape. So I'm going to pick that specific label. So looking at this particular labeling function, we found which ones are most similar. In the same vein, I can see which ones are least similar if I toggle this, and we could see these appear, the images that will be least similar. So we have representation for both present and absence when looking at this specific labeling function. And associated with our ground truth, we can see what's the precision numbers for both present and absence, as well as the recall numbers. This is going to guide us to determine what toggles we want to use when we create this labeling function. Now I have both most similar and least similar toggled how I would like it. The next step is let me add this labeling function to my already existing ones that I do have here. So the way I would do this is I'd create the LF, which stands for labeling function, and you'll see it appear to the left.
So that labeling function is going to vote round for the things that fall into most similar and not round for the things that fall into least similar.
Exactly.
Okay.
Next couple labeling functions I wanted to show you. One is going to be a text to image labeling function, and you'll see it looks similar to the image to image labeling function. So if I type in striped, I'll see which images are most similar to this term and which ones are least similar. And this would be the same process. I would choose the particular label, see which ones are most similar, which ones are least similar, and then the associated metrics. Another example of a labeling function I wanted to show is instead of doing an image to image comparison, we can take just a portion of the image and see which images are most similar. So I can look at this particular image and say, I just want to take a portion of it to encompass this particular shape. I can preview the labeling function, and same idea, what's most similar, what's least similar in the embedding space. And then I would pick the label associated and see my coverage, my precision numbers, and my recall numbers.
And we call this the patch approach, right?
Exactly. So this is the image patch labeling function that I'm showing you here. Our next step, now that we've added these different labeling functions we've created, let's train our first model and see how it does. Okay, so now that we've trained our first model, we're getting our results, our current F1 score. Our next step is to see where is the model having errors and how can we potentially improve these by either adding new labeling functions or improving existing ones. So we would do this by going into the analysis section and using some of the many tools we have available here. So the first thing I want to look at is we can look at the class level metrics, see how is the model doing on a class level basis. And we can see here it's doing pretty well on a couple classes like geometric and patchwork, but it's doing rather poorly on this animals class here. So the next thing I want to do is dive in a little deeper. I can go to the confusion matrix and particularly look at the animals class and see where are these different errors coming from and maybe what is causing the model to have this confusion. So I can see here it doesn't understand how to correctly predict when animal is absent for a few of these different data points. And as we pull these up, we can see similar patterns arise where it's thinking this zebra pattern should be labeled as animal, but we really want this model to abstain.
So you would cancel that out with another labeling function to say, don't call zebra animal?
Exactly. So let's go ahead and do that. I can click on this particular image and say I want to preview an image LF. And instead of saying we want to include this in the animals category, we're going to actually invert this. So I'm going to say when images are most similar to this pattern, don't label it as animals. So I'm going to kind of ignore this side and I'm going to focus on most similar to the zebra prints, we're going to abstain from animals. So if I toggle this, we can see which different images are incorporated, and we can see what are those numbers, what are those metrics with the absence category, and also view that all these look very much like that zebra prints. Adding this new labeling function that's going to have much higher metrics, much higher precision numbers, is going to outweigh that initial labeling function I have. So now under the Snorkel, we're able to choose the proper label for our training set. The next step would be to train that next model, see if we have improvement, and we could see from model 1 to model 2, if I show our different F1 scores from model 1 to model 2, we do have some small improvement, which is represented here in this graph. And just to dive a little further, we can see looking at that confusion matrix for animals, we are correcting some of these specific data points we were looking at, and we do have a much higher score in terms of precision for this class.
This is a friendly UI, but there's a lot going on in the background. So can you tell me about the embedding models and the math that's going on there?
Yeah, so we're using an open source clip model. So that model has been trained on a ton of different imagery. We can use it as a base and then guide it in terms of which images are most similar using both text and image-based labeling functions in this embedding space. But it's backed by that open source clip model that I mentioned.
So we have an initial model that was doing okay, and we did an update to it that's making it do better on particularly one particular class. What happens now?
So now we want to continue to iterate. If we look at this model, we see it's at about 89, 90 F1. We don't want to stop here. We want to continue to see where different errors coming from. We can look at other classes as well and see what do we want to focus on next. What other labeling functions can we add or improve to continue to get a better programmatic training set and then train a better ML model? And another aspect I want to add is we focus mainly on different images. We can also work with metadata. So for those multimodal problems where we have metadata as well as the images, we can do those as well.
Can you give me a toy example for what that might look like?
We can actually use this particular data set. If I want to go into the data view, I can see what are different text terms associated with these images. So we can use a pattern-based labeling function to represent this. One quick example, if I type in the term patchwork, so represented by the keyword patchwork, I can label this as patchwork being present. And I can quickly preview the labeling function.
So what you're saying is you can use information beyond the image itself to help with these labeling functions, which could be a huge use for perhaps, well, in Wayfair's case, they had a bunch of vendors who would put things up there with conflicting labels, and they can use those labels to sort of distill along with the image itself.
Yes, exactly. So it just gives you a leg up when you're able to start with these very simple text descriptions to add on to our programmatic labels.
Thank you so much to Daniel and Tom for that introduction of our image classification capabilities. This is going to really move the needle in terms of how we think about multimodal use cases in Snorkel Flow. So we're very, very excited to share that with all of you and get some additional feedback. Okay, so maybe rounding up really quickly here, you just saw 4 feature deep dives that are coming to you in the R1 release. The first was all about role-based access control and how we can really up-level the types of controls that enterprises have for data access and control. The second, again, was about LLM integrations and how we've really prioritized making it even easier to integrate with the latest LLMs and foundation models to power a lot of these data development workflows. Third, you saw how some of these foundation models can be used to drive workflows all the way from prompting in this prototype stage to fine-tuning for quality and throughput when you're ready to do so, all in one consistent workflow. And last, you just heard again from Tom about how Snorkel now supports image classification workflows to help with some of those multimodal use cases. That's not all that we shipped this quarter. Again, we have a set of continuous improvements that we've prioritized based on all of your feedback. You'll see some expanded deployment options in this release. with our partners over at over on the Azure side to help deploy some of your models to those cloud environments. We've made some significant upgrades to our data viewer so it's faster and more consistent throughout the platform and should generally be a much more pleasant experience to interact with for all your data exploration needs. We've also streamlined a number of the reviewer workflows for sequence tagging applications. So you can imagine that if you're actually trying to label with multiple teammates, certain sequence tagging or kind of token level applications, it's now a bit easier to actually review other people's work, look at overlapping spans, and reconcile any of those differences. We've simplified the LLM prompting UI based on feedback from a number of our users to make it easy to select different LLMs and map certain outputs with custom mappers to reformatted examples. So should really help with some quality of life there. We've also introduced one-click PDF span annotation. So a big feature request we've heard from a number of our customers is, hey, when you have certain documents where a lot of entities are irrelevant, it's actually easier to label all as other before changing or correcting the spans that actually map to a relevant class. So some of those quality of life improvements we've heard directly from our users and customers. And of course, one of the capabilities we're quite excited about is we've actually introduced beta support for chunking and retrieval augmented generation for some of the long documents that you might see in Snorkel Flow. This should make it actually far easier in that prompting interface to work over, again, long docs where there may not be the context relevant to the query you're focused on right away. So again, this is all just the subsample of what we've shipped in this R1 release. We're very, very excited to get it into all of your hands. And if you go to the next slide, you'll see some of our contact information. Please reach out to us. Please reach out to your success managers, info@snorkel.ai if you'd like a deep dive on any of these capabilities. We're very excited to get this into your hands. And again, all of this was rolling up to a broader theme of making it really, really easy for enterprises to take advantage of foundation models to power their highest value use cases and get those to production. So thank you so much. I believe we have some time for questions. Daniel and I are happy to hop on and spend some time with folks here. But yeah, thank you so much for listening to the content here. One common question I actually get just based on some of the workflows that we've showed is, hey, how what is your story around, hey, selecting a specific LLM provider, or what is your guys' point of view about the LLM of choice? And, just given all of the features this time around about accessing and selecting foundation models, the short answer is we're pretty agnostic to your choice of foundation model, right? We see Snorkel Flow is actually sitting on top of any sort of FM provider or LLM service. And, using a number of the capabilities which we've upgraded this time around, it should be actually quite easy to experiment and integrate with either an off-the-shelf LLM, something that's hosted on Hugging Face, or even an internal service that you may have spun up, using an internal, inference endpoint. All of those are possible ways that we can plug in. And again, Snorkel, we see ourselves as that layer on top to help specialize those LLMs for downstream use cases. So just wanted to share that more broadly. It's a common question we have here.
Yeah, in terms of a common question from my side, on the enterprise side, one of the things that we've been focusing on recently is data governance. So as you might know, or as I explained in this webinar, we're primarily focusing on data ingress this quarter. But the question naturally is, what about data at the perimeter that is leaving Snorkel? So we will be doing a lot of new changes coming out in the R2 release in a couple months, specifically focusing on locking down how data exits Snorkel altogether, which we're really excited about. On the computer vision side, another common question is, outside of the Wayfair use case, where have you seen success? And one of the things that we weren't able to go over today, but we're generally very excited about, is satellite imagery. We have done some work with a federal partner, specifically the National Air and Space Command, that demonstrated that Snorkel's computer vision technology, using the open source foundation model that Tom went over, actually works really well for aerial electrical optical imagery in the federal case. So that's exciting as well.
if our document library contains multiple languages, can we compose a translation to get the text into a common language or automatically convert some of our labeling? That's actually a really interesting idea, Jim. It is something that we've tackled before. We have an SDK notebook where you can do some of this more advanced translation. One of the nice things, just to nerd out for a second about how we think about labeling functions, is that they're actually a form of weak supervision. We've been leaders in this space from the academic side for quite some time, and it's basically robust to noise in labeling sources. So if we were to say translate over from different languages, that's actually quite a powerful way to take some of those signals, even if that translation is a little bit lossy or is a little bit imperfect. So short answer is absolutely something that is certainly worth trying in terms of accelerating, a multilingual application and translating, the types of signals you have across use cases. I saw another question here from Jim. You'd asked about Apache Tika. Yeah, I'll check with our field teams about whether we've specifically leveraged this library. More broadly, we have integrated, pretty flexibly with any sort of document processing or metadata extraction toolkit. So I have confidence that using SDK, you could certainly pull out some of those inputs and then leverage them in the platform for labeling function development or, any sort of downstream processing. So short answer again is yes, this seems compatible with our platform.
Okay, seeing an empty question queue and not seeing any more common questions, I will wrap it up. So thanks, Vincent and Daniel, and of course to our entire audience for being here today. Thank you for your time, for joining us today, and we hope to see you again soon at a future webinar or event. Have a great rest of your day.
Thank you, folks.
Thank you. Bye-bye.